Okie dokie, in this video we're covering homework 7 separable equations and modeling. Starting with question 1, we'll probably do this homework in a few different parts. Starting with number 1, for this differential equation, this initial value, use Euler's method with a step size h of 0.1 to approximate y at 0.6. So we're starting at y of 0 equals 4. So we're starting at a y value of 4, and our step size is 0.1. So we have to go up by 0.1 each time to approximate the y value at 0.6. So we're doing Euler's method 6 different times. Let's get started. We use the previous or like initial y value. So 4 plus the step size, which is 0.1, times dy over dx with the previous y value, in this case, plugged in. So 2 plus y would be 2 plus 4. So we get 4 plus 6 times 0.1, so 0.6, so we get 4.6. And then we use that as our next, starting point. So 4.6, so just to be clear, 4.6 is the approximation of the y value at 0.1, at t or x equals 0.1. So we use that to then approximate the next y value at 0.2. So then we do 4.6 plus 0.1, the step size, times the dy over dx of 2 plus y. And again, we use the previous y value, so 4.6. And so we have 4.6 plus 0.1 times 6.6. So that would be, if it's 6.6 times 0.1, that'd be 0.66. Yeah, so now we have 5 point something. I don't want to get it wrong. I'm going to go 5.26, I believe. Hope that's right. Let's keep it going. 5.26 is the next starting point. It's at this point I'll probably use a calculator. So we have, again, previous y value plus 0.1 times 2 plus the previous y value. So 5.26. We get 5.26 plus 2, that'd be 7.26 times 0.1, so that'd be 0.726. Okay, here I will use a calculator. So let me just go ahead and confirm the last one just to make sure, extra sure. So we have 5.26, good. So now we're gonna just add 0.726 to that. So we get 5.986, okay. 5.986 as the result for y of 0.3. So we're halfway through. So y of 0.4 would be 5.986 plus 0.1 times 2 plus 5.986. And we're going to get something for that. So I might try to Desmos it the rest of the way out because hopefully you get the pattern here. So we're going to do 5.986 plus 0.1 times 2 plus 5.986. Okay, so we get 6.78. So I'll type the rest of these. So in this second box here, I'm about to type y of 0.5. So it's going to be the previous y value, 6.7846 plus step size of 0.1 times the dy over dx, so 2 plus the previous y value, so 2.7846. We get 766. So now we can calculate y of 0.6. So we use the previous 7.66, 306, plus 0.1, the step size, times 2 plus 7.66, 306. And we get 8.6294. 8.629 to 3 decimal places. 8.629. That is Euler's method to approximate y at 0.6. Hope that made sense. Let's keep it going. Number 2, once again, Euler's method, dy over dx, initial value, step size, y, 0.4, blah, blah, blah. Okay, so y of 0 is equal to 8. And we're approximating with step sizes of 0.1 to approximate y of 0.4. So we're going to do 4 iterations. Let's do it all in Desmos because I don't want to write it out. So follow along with me. Approximating y at 0.1. The first one, we use the starting y value, 8, plus the step size, 0.1, times dy over dx, which is 2x minus 9. So we're going to have 2 times x, which is the previous x value. So 0. We use the previous x value, just like in any other case where we would use the previous y value, right? So we're using 2 times 0 minus 9. And that gives us 7.1. So 7.1 is our y at 0.1 value. So maybe at least I'll jot these down. So I'm going to say y value at 0.2, y at 0.3, y of 0.4. Okay, so 7.1 for the first one. Let's keep it going. 7.1 plus the step size times 2 times x, which is 0.1. So the previous x value was 0.1. Okay, and then minus 9. So we have 6.22. Let's keep it going. 6.22 plus 0.1 times 2 times x, which is 0.2. The previous x value is 0.2 because y of 0.2 was 6.22, and then minus 9. So we have 5.36. And then we got one more. We got 5.36 plus 0.1 times 2 times the previous x value, which was 0.3, minus 9. And we get 4.52. And that should be the approximation using Euler's method of y of 0.4. Okay, let's keep it going. See if we can do even